Okay, calculus kids, here we go. Problem number 2 of 2013 is the first one we start with. You're given a velocity function, v of t is equal to -2 plus t squared plus 3t raised to the 6/5 power minus t cubed. And you also know that s of 0 is 10. And what that means is at time 0, the position is 10 units. And question A says find all values over the interval 2 to 4 where the speed is equal to 2. Now, speed is the absolute value of velocity. So we're looking at the absolute value of velocity is equal to 2. And so if we just set up this calculation, absolute value of velocity is equal to 2, or absolute value of velocity minus 2 is equal to 0, what I can do at that time is I can go to my calculator. As I turn my calculator on, clear that, and I type in the function for velocity, -2 plus x squared plus 3x raised to the, I'm going to use parentheses around that 6/5, and minus x cubed. And so I have that. And what we're going to do is I'm going to go back and I'm going to put absolute value symbols around that. Second insert and second catalog, that gives me absolute value. We've talked about this before. And so the absolute value of that guy. And then I'm going to hit a -2 because I want to do -2 is equal to 0. That's the equation I want to solve. And I'm going to zoom standard, zoom 6, see what I get here. And I'm looking from 2 to 4. And if you look here, it looks like this is a spot, that's a spot. If I kind of scroll here, I can see that once I get to 2, I'm really looking for this area right here, these two. So I'm going to zoom, and I'm going to zoom as a box. If I zoom as a box, kind of this area here, I can see what satisfies this equation. Now, on the AP exam, you need to answer three decimal places. So what I'm going to do is I'm going to second calculate the 0, number 2. I move to the left, move to the right, press enter on guess. I get a time of 3.127. Time is equal to 3.127. And then I'm going to calculate number 2 again. And as I move off to this side, enter, enter, enter on guess, and I get a grand total of 3.473. 3.473. Now, the AP exam wants to see these equations set up, that absolute value of velocity is equal to 2, so on and so forth, your final answers. It doesn't give us a time restriction in terms of whether we're looking like a label, like seconds or anything like that, but that's what I got. Part B says write an expression involving an integral that gives a position, s of t. So position, we've talked about this before, position is equal to the start plus the displacement. Well, the displacement of an object is simply the integral. It's simply the integral, okay? And we're going to go at time t of, from 0, of v of t dt. That's the displacement. What's the start? The start is 10. It starts at position 10. So s of t, the position, is equal to that integral expression right there, okay? And so it says then calculate the position of the particle at time is equal to 5. So the time at 5 is equal to 10 plus the integral 0 to 5 of v of t dt. So I'm going to again use my calculator for that guy. I turn on my calculator. I go in here and I'm going to delete the absolute value piece. So I've gotten rid of that and delete that parenthesis and the -2. So that's my original integral. I'm going to zoom 6, go back into that window, and I can see my function. And I'm going to go second calculate number 7 from 0 to 5. I'll go ahead and do that really cool thing that we like to see it do. It gives me negative 19.207. So 10 plus negative 19.207, and that's equal to negative 9.207. That's the position at time 5. So you can see that. We move on to example C here. It says find all times in the interval at which the particle changes direction. Where velocity changes from positive to negative or velocity changes from negative to positive, that's where it changes direction. Again, all this work is stuff that the AP exam really likes to see. And you can check out the answer key to see exactly what they put. But that's what we're looking for. So I'm going to look at this graph again. I'm going to go into y equals, I'll just type that negative sign. Again, I'll get a clean graph here. And that's my velocity graph. And so find the time which a particle changes direction from 0 to 5. Well, if you look here, it looks like it changes direction right there. Okay. And as I move over to this side, move over the cursor, looks like right there, the velocity changes as well. So I'm looking for those two spots. So I'm going to calculate 0, and I'm going to go a left bound and a right bound. So I'm going to say v of t changes negative to positive at time equals 0.536. Okay. And then as I check that again, number 2, the 0, I'm going to head on off to this other 0. And I'm going to go back, press enter for a left bound, enter on a right bound, enter on guess. And I get 3.317. V of t changes positive to negative at time is equal to 3.317. And it says justify your answer. Justifying your answer, it really says that you're looking for where the velocity function changes sign. That's the really important part there. Finally, D, it says, is the speed of the particle increasing or decreasing in time is equal to 4? Well, we need to check V of 4, and we need to check A of 4, the acceleration at time 4 and the velocity at time 4. Whoop. Velocity at time 4 and acceleration at time 4. So I go into my calculator. This is the velocity function. In order to calculate a value, I do number 1. And I'm going to calculate the velocity function at time 4. I get negative 11.475. And then finally, the acceleration. Acceleration is the derivative of the velocity function. I do that by calculating number 6. And finding the derivative at number 4, it gives me negative 22.295. So the particle speed is increasing at time equals 4 because V of 4 and A of 4 are the same sign. And that's really good work there. This is, you would then just take a photograph of this, send it on in, but that's good work. Motion of particles is one of the most common questions asked on the AP exam. You see that took us about 10 minutes to get through. And this is something we practiced before, which is why I started off with this. So there you have it. We'll move on to our next one.